This meeting is being recorded.
Oh.
All right.
All right. Um, so let me share my screen first, and I'll do a small presentation. You can see my screen, right?
Yes.
Okay. So this is just 5 slides for like why, you know, all of us can agree that we prefer to work in these kind of hub deployments than trying to build our environments ourselves. And scientists, of course, they they really like it because they don't have to deal with all the shenanigans of software packages. And when something is already packaged for you, then you dedicate yourself to the thing that you like or the thing that interests you the most. And I think that's the big secret behind some of the most successful software, right? In our environments, we're very familiar with JupyterHub deployments. When we started in Openscapes, they rightfully approached this 2I2C organization that it's a nonprofit that spun out of the JupyterHub world that basically offers the deployments as a service. So these are, of course, dramatizations of what scientists can encounter in a day-to-day. One is like, okay, so I need to work in this thing, and it only works in this particular browser or in this particular operating system, and or you can go to a JupyterHub deployment and just start working. And this has been brought up by the Pangeo community several times, and like what the cloud deployments will address at the end, right? So one of the main things is big data, and particularly with remote sensing stuff. Or there are other domains that have big data for sure. Uh, but that's kind of like the main selling point, but that's not the only one. And I would argue that it's not even the most important one. I would say the most important one would be productivity, like jumping to what you want to do and kind of like filling the gaps that these cloud deployments try to address. So the big data is one that it's important, but it's not the only one. So you have the technology gap, the skills gap. Like, do you really want your users to start dealing with this stuff? Well, I don't. And the last one is reproducibility, which is like, I want this to work every time, right? So in Openscapes, we leverage the 2I2C infrastructure. They produce or they offer this deployment as a service. Uh, and they are basically in charge of all the Kubernetes things with the cloud providers. In our use case, we're only in the Amazon realm because that's where NASA data is. But Pangeo, for example, most of their hubs are in Google. And eventually, the planetary computer is in Microsoft Azure. So if they have like a particular data set, it will make more sense for a user to deploy that there. 2I2C would do it. And 2I2C is not the only, the only game in town. There are other companies, but they are fully open. So the infrastructure charts for Kubernetes are open, and that's pretty valuable, I think. And they have been really great to work with. So no complaints there. But well, there is one complaint, and that is like the feedback loop is kind of sometimes not as quick as we want. So for example, when you start with them as a, say you are a university or you are a researcher and you want to start your own JupyterHub deployment, then you have to open tickets for the things that you want in your hub, and well, they are busy, right? And I don't think they have enough people to, like, and they're pretty responsive, but then you might wait for like a couple of days or a week until they get back to you and they deploy the thing. So at the start of Openscape, that was kind of a blocker for us, that we wanted to test things. So that's what we decided to close the loop and create our own deployments for our Jupyter-based image. And the Jupyter lab that we use is basically tailored for geosciences. we're deriving the Docker image from the Pangeo one, so we don't have to worry about some basic stuff as they usually do, best practices. And one of the things that we do is, you know, session persistence, GitHub authentication. It's always deployed to US West 2. And one of the cool things is that we can support multiple kernels. And of course, we have DAS Kubernetes, which is a plugin that will spawn a cluster inside the Kubernetes world for the users in case you need to work with big data. We haven't used this in depth because of the skills gap and because we haven't had like, you know, something that actually requires a DAS cluster yet. And the way it works is the following. So you have normally, if you're a Python user, you have your environment files. In our case, we have our main environment file, but that's not we're not limited by that. We can have different teams working on different things, and you know, sometimes they're incompatible ways of working with one another, like Python versions. Like if there is something that definitely differs from the main environment, you can create your own. Once that you push that, there is a GitHub action that will, you know, build the Docker image and deploy it to the Docker registry. And it used to be automatic that once that's pushed, it will auto update the hub. But then we run into issues that we switch the environment for users that didn't want to. So it's not that we're doing work in progress. So it's not fully a CD yet, or was, but we kind of cut that off. And now it creates a PR for 2I2C that, hey, there was an update in the environment. Do you want to merge it? And once that they merge it, they deploy it for the next time that we spawn our instances. So that's basically in you know, high level what we do. And this is only this slide is only focused on the Python thing, because the key aspect of the Korn environment, what it was called Korn because it can support multiple kernels, but is that we're in charge of the continuous deployment. So we don't depend, for the most part, on like opening a ticket for, hey, I need GeoPandas version 1, 2, 3, and then somebody in the other end will like, okay, let me see if it's, you know, it's all automated. And of course, there are like some shortcomings of the environment that are not as easy to address. But for the big parts, I really like this setup. We can have a build in like 20 minutes from end to end, deploying and working. And that's basically, you know, the how we started with Openscapes in the Python. Now, I wish I could rerun the same slide with a different language, because it will be the same story. Like, oh, guess what? Now our users are not necessarily using Python. We had a lot of users that were like asking for R deployments and MATLAB some. So we used the same approach for creating a GitHub repository that was building the image for that language. And the reason for that is that it's kind of difficult to make things compatible, even within Python alone. Like the best practices for each languages are not the same. Like the R-based image is based out of Debian, and most of the deployments for the Pangeo Docker images are based out of Ubuntu. So from there, you have like ways to, or not ways, but different conflicts that wouldn't be fun to solve there. So we ended up building 3 different images for the 3 different languages that we support so far, and that was a recent thing. And so that we have, when you go to the hub, you have the options, right? So the default is Python because that's what we normally work on. But you can also use MATLAB or R, and it will spawn either RStudio, you know, the launcher, or the MATLAB cloud something with your license. So MATLAB is all license-based. So if you bring your own license, you plug the license, and it will automatically link your license to the things that you bought or the things that you are able to access with that license, and you'll use it in the cloud. So it's the same concept. Um, so the workflow, as I was showing to you, it's very simple. There is a repository called corn. There is an instruction here, like if you want to create your own kernel, you can do it just by adding an environment file. And this one is just laziness of not parsing the environment file, but we can later do it. That you have to add a name.txt, but it doesn't have to be like this. It can just use, well, eventually should use only the name of the environment.file. And one last thing is that every time that we do this, we create conda log files for the 3 platforms. So we can, if we want, use this environment in local mode with the environment files. We will need to expand the README, of course, to, like, I think in NSIDC we have a better README. Like, how can you do it locally with using just conda without having Docker? Although my preference is always to use Docker because, like, it's the whole stack. And then that image ends up being here in the Docker Hub registry. So anybody can just, if they have Docker, of course, or you can install it, they can just pull the image, the say pull Openscapes Python, and they will be running the same image that we're running in the hub. So it's very straightforward, the way to like interact with our environment. And one of the things that I kind of dropped the ball was the first and only issue in the repository. Somebody said like, oh, I would like to actually use Binder with this. So yesterday I started working on that. And now you can even use it in Binder. So where is the link for that? Let's see. Well, I'll later paste it on the chat, but you can use Binder to build the same image with the caveat that that Binder image will be running most likely on a cloud, on a Google Cloud environment, which means that you cannot do direct access to S3 for NASA data, but you have the environment. So you've probably seen this. Once that you spawn an instance, it will takes like a couple minutes. There is this is on the 2I2C side that they have to instantiate a machine if they don't have the pod in the Kubernetes cluster, because you don't want to spend money. They downscale the cluster whenever possible, eagerly. So that's why, except when we have like hack weeks or something that they pre-warm it, so the users are not waiting for like a couple minutes or 5 minutes to get a new instance. It's all money, right? You can have a better availability with, you know, if you had on demand and not, you know. But once that you instantiate your instance, you get the environment that I was talking about. And in this case, we have a Jupyter lab with the Dask launcher for a Dask cluster. You have other utilities that are kind of used in our world, like out of the box, you get all the netcdf, HDF5 libraries installed in the image, and also you can do stuff in the terminal. So if you're not feeling comfortable with Jupyter notebooks and you rather do like netcdf, nc dumps in a file, you can do that. There is a limitation on the storage. Right now, I think we're kind of like, but this is normal for cloud environments, like in the 20 gigabytes or 15 gigabytes for user in what AWS calls ESB volume, or basically it's just an attached virtual drive. So when our users turn off their machine and say, well, the next day, if they save the environment in their home directory, or they save their work in their home directory, it will be there the next time that they, you know, get back to that. It's not a lot of space, but it's not meant to like stage a lot of data either. So now it's working. It's pulling my, let's see, it's pulling. Yeah, perfect. It's pulling the image that I created, that we pushed the last time before I started to do this stuff. So that's 3 months ago. Now it's taking a little while, but eventually we'll get there.
Luis, there's a
Questions so far?
question.
Yeah.
Yeah, there's a question in the chat from Bree. What's the difference between an environment and a base image?
Well, good question. Like I use environment for different levels of abstraction, right? In the Python world, an environment, it's defined by your conda.yaml. So that will be like the set of dependencies and versions of those dependencies that you want. Now, the base image is the Docker image that builds those environments for us. So you have a Docker image with one or many environments in it. So we've been working with one because so far we haven't had the necessity of actually, including more environments. But you see those environments in a second if I'll get to, let me see. Okay, this is a starting. This will pull my our latest, not our latest, but the last main that we built. So this is what the users see, right? Let me change my theme. So it's more like what the users see. I like dark. And they only get one environment. So these are exposed to the users in the way of buttons here that are called kernels. So sometimes you see, like even from a different language, you see Julia or MATLAB that we have in our other base images. In this case, since we instantiated the Python image, we only see the Python kernel 1. So this button means create a notebook with this environment or create a console session with this environment. And by default, we'll open the notebook using the default environment. But there are cases, as I said, where you might need a different Python version or a different package that will not be otherwise compatible with the default environment. And that's what the corn base image do for us. The instructions are there for how to add one. And I added one in the last build. So if I'm gonna run it locally. Okay, so I have it somewhere running here. I think. Nope. Okay. Let's see. Docker. I'm live deleting Docker images. Okay, so now it's starting in my local. Let's see. Okay. Okay, so this is what will look like if we added another environment. If you can see, there is another button here. This is the default environment. This one is one that uses Python 3.8. Like if we do, yeah, it uses Python 3.8. And this one has PyDeck installed. So where is that thing? Let's see. I was looking at PyDeck. Oh yeah, so here. PyDeck is a library for 3D visualization. We don't have it in the Openscapes environment because we don't need it. But this one has it. So we can actually run PyDeck in here and see, right? Like, oh, cool. You have a 3D visualization of like population density in England. So that's basically what the corn environment will allow the users to do, to be in control of their own kernels. so they don't have to open an issue to get to here. Because that's sometimes, as I said, if you want to see results like, okay, so this library for some reason wasn't the version that I needed, I need to upgrade it, and then you have to wait a week. that will be like kind of like old. So we do this in CI. Our image gets built, the environment in the Python world, excuse me, gets built, and you see them as buttons here for your environment. And we are in the process of doing the same. I'm not super familiar with R, but I know R does the same thing with R environments. The thing with R is that most users don't really use environments. They're also kind of like working in kind of the JavaScript world, where you install the libraries in the local project and they just work like npm does. But there are ways of reproducing the environment, and I think one of the champions is like really, his team is I think he works at Mount Sinai something genomic. And they do all these workflows in R for biostatistics, and they do use these environments for reproducibility. So that's the gist of it. I really like the way we build the CI/CD for Corn and the Openscapes environments. The thought is that we'll do the similar thing. Well, for MATLAB and R, we only have general environments. We don't have, managed virtual environments like we do in Python. I don't know if we will get there, but it's possible. And this is what the admins see. Like, you see who's running an environment, and like you can even, as I said, spawn servers. If you want a different machine with a different image, you can like go and do that. I haven't, where's the hub control? Oh, this is my local. Yeah, hub control panel. You can create a new server with a different image. I haven't done this. I think Jack McNeils from Podak did it for some experiments, but not a lot of people have seen it using this. So you can technically have like one image with MATLAB running, and the other in a different browser will be your Python environment if you want to, And the other thing is that all this information is particular to you. So it's not like anybody can see this except for the share folder. That is, I think, another 100 gigabytes or something of shared space. So we all see this. And if you want to share something, and we've been kind of like using it as a staging directory, and we put stuff there and other people can see it. And so that's really useful. And of course, there are other things particular to the Python JupyterLab world, like these plugins that lets you do the Git stuff from the plugin. And as I said, the terminal that you can like personalize if you want. Like I like C shell instead of bash. And you have like stuff like htop if you want to see like how things are running. If you're running a process that, oh, this is taking forever. And because I'm a Vim user, I installed NeoVim. So technically speaking, you can have, a NeoVim or Vim. Not technically, you can have this running in the cloud. If you're more familiar with this, then, So that's what it is. It's very basic, but it kind of serves our needs. We haven't pushed it to the limits yet, but I'm looking forward to it. I think we can do something similar to this with OpenSAR Lab, and they I think they do also. They are here, so they can correct me if I'm wrong, but they are basically their own 2I2C. So one of the cool things is that we don't have to deal with the actual bare metal deployments or cloud deployments in the Kubernetes world. It's not the end of the world, but it's not simple. It's not something that we like to do, because I mean, like, who's going to do it? In terms of full-time employee that you need to be there. But the approach is very similar. they tailor their deployment for SAR processing, which is, it's a little bit more on the heavy computation side of things. And with the upcoming mission of NISAR, it'll be, I think it'll be even more important to have this kind of deployments. And that's going back to my first or second slide about why we do these cloud deployments. And that'll be like, there won't be other way to process R unless you're in the cloud, for example. And that's getting more normal. But to me, as I said, is also the reproducibility and the how easy it is to use the environment. So as you notice, when we came to the hub, it was just a click selecting your environment, and you have your environment, and it'll be there the next time. So I'll stop there. And of course, we're not the only ones doing this. I think we're just following the lead of other great projects. I see a lot of things in the chat, but when you have the screen share, you cannot see the chats.
Awesome. Thanks, Luis. I will stop recording now so we can have a discussion if that sounds good to folks.